Loadrunner is a performance testing tool which was pioneered by Mercury in 1999. Loadrunner was later acquired by HP in 2009. In a recent assessment, Loadrunner has about an 85% market share in performance testing industry. The topics covered in this tutorial are: why choose Loadrunner? Loadrunner Architecture. Load testing process. So let's look into the details. Why choose Loadrunner? Loadrunner supports various development tools, technologies, and communication protocols. In fact, this is the only tool in the market which supports such a large number of protocols to conduct performance testing. Broadly, Loadrunner supports RIA, Rich Internet Applications, Web 2.0, HTTP/HTML, AJAX, Flex, and Silverlight, etc. Mobile, SAP, Oracle, MS SQL Server, Citrix, RTE, Mail, and above all, Windows Socket. There is no competitor tool in the market which could offer such a wide variety of protocols vested in a single tool. What is more convincing to pick Loadrunner for performance testing is the credibility of this tool. Loadrunner has a long-established reputation, as often you will find clients cross-verifying your performance benchmarks using Loadrunner. You'll find relief if you're already using Loadrunner for your performance testing needs. Loadrunner is tightly integrated with other HP tools like Unified Functional Test, QTP, and ALM, Application Lifecycle Management, which empowers you to perform your end-to-end testing process. What is Loadrunner Architecture? Frankly speaking, the architecture of Loadrunner is complex, but we will understand its architecture solving a set of problems. Problem 1. Suppose you were assigned to check performance of Amazon.com for 5,000 users, a very small traffic for such a huge website. How is it possible to arrange 5,000 people to access different sections on Amazon all at the same time? Well, it is practically very difficult to organize 5,000 human users, physically operating 5,000 different computers to access Amazon.com all at the same time. Consider what will happen when we test with 100,000 users, a more realistic number for a site like Amazon. Just imagine the manpower and equipment costs. The solution is to use software to simulate real users, who can access the website and perform operations. These users are called virtual users, or V-users. This is achieved using the agents machine, or load generators, or injectors component of Loadrunner. Virtual users emulate real user behavior. They help overcome resource limitation by replacing testers with virtual users. Problem 2. In a real-life situation, all 5,000 users for Amazon will not be at the home page, but in different sections of the website. To make load testing effective, our test should be as close as possible to real-life load situations. How can we make V-users access different business processes? The solution is VUGen. VUGen, or Virtual User Generator, is an IDE, Integrated Development Environment, or a rich coding editor. VUGen is used to replicate system under load, SUL, behavior. VUGen provides a recording feature, which records actions performed on the system under load in form of a coded script, also called VUser script. So considering the Amazon example, VUGen script recorded the following business processes. 1. Surfing the products page of Amazon.com. 2. Checkout. 3. Payment processing. And 4. Checking my account page. These recorded business processes can be later replayed by the V users. Problem number 3. The load generator will simulate users, but how do we control which users will access what section of the website? Enter the controller. The controller is the primary component of Loadrunner, which controls the load simulation by managing how many V users to simulate against each business process or V user group, behavior of V users, ramp up, ramp down, simultaneous or concurrent nature, etc. The nature of the load scenario, for example, real life or goal-oriented or verifying SLA. Which injectors to use, how many V users against each injector, IP spoofing, error reporting, transaction reporting, etc. Taking from our Amazon analogy, an example controller will add following controls to the script. 1. 3,500 users are surfing the products page of Amazon.com. 750 users are in checkout. 500 users are performing payment processing. And 250 users are checking their My Account page only after 500 users have done payment. Note: a controller can itself simulate thousands of V users, but V users consume hardware resources like processor and memory. Plus, the controller needs resources to govern itself. Using controller to monitor the test and generate V users as well may not give precise results. Hence, using load generators is recommended. Load generators are nothing but high-config machines. The number and configuration of these load generators depends on the number of V users and the protocol being tested. For example, if one load generator can simulate 1,000 V users, we will need 5 machines. Once load scenarios have been executed, the role of analysis component comes in. During the execution, controller creates a dump of results. All the errors and exceptions are logged in a database. The analysis component reads the database file to perform various types of analysis and generates graphs. These graphs show various trends to understand the reasoning behind errors and failure under load, thus helping figuring whether optimization is required in system under load. That's all to this tutorial. See you in the next one.
Now, for all hands on purpose, we'll be using the Mercury Tour's website, which comes bundled with the Mercury Roadrunner. So it would be nice before we have a look at the hands-on. Let's have a quick short introduction to the Mercury Tour's website. Click Start, All Programs, Mercury Loadrunner, Samples, click on Web, Start Web Server. The web server will start. An icon is stored in the systems tray. Again, this time click the Mercury Tours application. The home page of Mercury Tours opens. There are two basic links here. One is the sign up, other is the administration link. And let's look at the administration link. There are various options provided which change the administration profile of the server. Let's keep the default settings as of now and returns to the Mercury Tours home page. For sign up, enter a suitable username. And a password. The first name, address, and the city. Click continue. Since you've just signed up, you can directly click continue to log into the application. On a fresh startup, you need to explicitly mention the username and password here. I'll click continue for the time being. I'm taken into the Mercury Web Studio application. The application is mainly designed to book a flight. There are 4 buttons provided: flights, itinerary, home, sign off. The flight section is used to book flights between different cities. The itinerary section is used to see the different bookings done by a particular person. The home button takes you to the home page, and the sign off logs you out of the application. I'll click on the flights button. Here I'm provided an option to select the departure city, the arrival city, the date of departure, the return date, number of passengers. Again I can choose the seating preferences and the type of seating. So perhaps let me book from Denver to London, keeping everything default. I'll choose a seating preference as aisle and click continue. There are 4 flight options provided to me. I choose the flight at 1 p.m. Click continue. My payment details are pulled up for my registration data. I need to enter my credit card number, and an expiry date needs to be mentioned. I click continue. An invoice appears. I have an option here to book another flight, or I can click on itinerary button to see my itinerary. Here in the itinerary section, I have an option to cancel this flight using the cancel check button, or I can use the cancel all button to cancel multiple bookings in case they are available. I click the home button. That takes me to the home page. I click sign off, and that's the application for you. After the Mercury Web Tools, let's run the demo script and glance at the various components and functionalities of Loadrunner. Loadrunner, click Start, All Programs, Mercury Loadrunner, and click on the icon Loadrunner. At startup, you will see the license information. I'm using the trial version of Loadrunner, wherein I can use the software for 10 days freely. It is highly recommended that you complete the tutorials within 10 days. Click Close to proceed. This is the Loadrunner started page. There are 3 sections here: create and edit scripts, which is nothing but the view generator; run load test, which is nothing but the controller; analyze load test, which is nothing but the analyzer. Let's start with view generator. Click on the link create and edit scripts. The virtual user generator it's loading. This is the startup page. What I'll do is I'll just open a existingly recorded script. To view the script, I click on the button Script. Here I see the script being recorded. These are the various steps that are recorded in the script. So any transaction that you do on your application under test is recorded here, and this is the virtual user generator. Second, to run the load test or to start the controller, click on the link Run Load Test. Select the various scripts you want to include in your Loadrunner scenario. I'll select the script which is named basic_script. Click OK. There are two sections in controller, the design section and the run section. Let's look at the design section first. The design section is the one in which you set up the runtime settings. I can specify the number of users I want to access the system. Right now the default is 10. I'll make it say 8. Correspondingly, I see a change in the load preview. I can also mention the machine on which I want to run the load scenario. There are many other features here, ramping up, ramp down, and so on. We'll stick to a very basic scenario. Click Start Scenario. The scenario will start running. There are various performance matrices which could be measured here. They will be captured during the run. Here you can see the status of the various virtual user generators. The script is run and passed. Now, I have an option here. I can save the results, switch back to the third link, analyze load test, and open the results there, or directly in the controller section I can go to results, analyze results. The analyzer is launched. Which gives me a summary of the various transactions and their response times and a plethora of graphs. So this is a very quick preview of Loadrunner. Virtual user generator. Before we look at the virtual user generator, a quick glance at a few definitions. Virtual user. Loadrunner emulates the environment in which thousands of users work with a client-server system concurrently. Loadrunner creates or replaces human users with a virtual user, also known as the V-user. Virtual script. The actions performed by the human users are recorded in the form of script. The script generated by the Loadrunner is V-user script. The scripts when replayed emulates the real user performing the business actions. The scripting language uses C, C++, Java, or TSL, which is nothing but transaction scripting language, a proprietary language. Actions. Actions are a set of user transactions performed in an application to accomplish business task. Each virtual user script will always have three default actions. First, the VUserIn used for logon into the application. Actions used for business actions that need to be recorded. VUserIn used for log off from the application. The virtual user generator, also known as a VUGen, enables you to develop user scripts for a variety of application types and communication protocols. VUGen not only records user scripts but also runs them. To verify that the script runs correctly, you run it in standalone mode. When your script runs correctly, you incorporate it into a Loadrunner scenario. The script development process is record the script, replay the recorded script to verify the scripting was recorded properly, enhance the script for any transactions or checkpoints if required, replay the script again to verify everything is working fine, configure various runtime settings like number of users, load duration, browser settings, and so on, and use such a script for a load scenario. How recording is done in Loadrunner. ViewGenerator does not record the activities performed by the client on the application. Instead, ViewGenerator creates a script by recording the activity between the client and the server. To understand the concept better, let's observe and compare how client actions are recorded in QTP, a flagship function texting tool, and Loadrunner. The task at hand is to enter a quantity 1 in shopping cart of a web retailer and click the button Place Order to complete the order process. In the background you see the QTP window. In the foreground is the Mercury Tours web retailer. We assume that the QTP is in recording mode. The user enters quantity equals to 1. In QTP window, a step is recorded which sets a quantity edit box equals to 1. The user clicks the Place Order button. In QTP window, a step is recorded which clicks the Place Order button. In the website, the user is taken to the order confirmation screen. Now, let's observe and compare how recording is done in Loadrunner for the same order process. For a note, again, I mentioned, Loadrunner will only record communications that take place between the client and the server. Assuming Loadrunner is in recording mode, user enters quantity equals to 1. Since there is no communication between the client and server, no event is recorded in Loadrunner. User clicks Place Order button. Here, client does send the order information to the server and an event is recorded in Loadrunner. Let's record a script in View Generator 2. Log in Mercury Tours, book a flight, view the itinerary, and sign off from the application. To start Loadrunner, choose Start, All Programs, Mercury Loadrunner, click Loadrunner. In the launcher window, click Create and Edit Scripts to launch View Generator. Under the Scripts tab, you see two options: to create a new virtual script or to open an existing virtual user script. Click New User Script. The new virtual user dialog box opens. Here you have an option to create a single protocol script or a multiple protocol script. Just for a background, a protocol is a language that your client uses to communicate with the backend of the system that is nothing but the server. If you create a multiple protocol script, you can record multiple protocols in a single script itself. For a learning purpose, we will stick to a single protocol script and select the web protocol since the Mercury Tours is a web application. Click OK. The ViewGen wizard mode opens. On the top you see the toolbars. On the left hand side there is a task pane. In the middle it's an instruction pane. The ViewGen's wizard takes you through a step-by-step process of creating a script and then adapting it to your test environment. The task pane will list each step or task in the script creation process. As you proceed through each step, ViewGen displays detailed instructions and guidelines in the main area of the window, that is nothing but the instructions. Now after the introduction, let's move ahead and record a business process. We'll track and record the events of one passenger reserving a flight from Denver to Los Angeles, then clicking the flight itinerary before finally logging off from the application. To start recording, click Record Application in the task pane and then click Start Recording from the instruction pane. Alternatively, you can also click Start Recording from the Tools menu bar or from the File menu, View User, Start Recording. The Start Recording dialog box opens. Here in the URL, you can mention the web address of the site under test. Also, you have an option to choose the action where you want to record the events. Click on Options. In the script node under the journal section, you have an option to choose the scripting language. Since we are using a demo version, the only language available is C. Otherwise, you have C++, Java, and so on. The protocol node gives you the various protocols to be recorded. Under the network section, the port mapping node gives you the port mapping. This option is available while recording multiple protocol scripts. Say for example, you have a network traffic coming in from multiple protocols like HTTP, SMTP, POP3, FTP, and you want to record traffic from a single protocol, say HTTP, so you use port mapping. The recording node gives you the various recording options: HTML based script or a URL based script. The HTML based script gives you steps generated for each HTML user action. The URL based script captures all requests sent from browser due to URL action. It is not as intuitive as HTML based script and is recommended only while recording pages such as applets or non-browser applications. The advanced node gives you the various advanced protocol related settings. Let's stick to the default. The correlation node gives you the various correlation related settings. Click OK. In the Start Recording dialog box, click OK to start recording. The floating toolbar gives you many options like stopping, pausing, recording, transactions, and so on. Log in the Mercury Tour's website. Enter username Nick and a valid password. Click Login. Click the Flights button. The departure city is Denver, default. Select the arrival city as Los Angeles. Select the seating preference as aisle. Rest of the settings being default, click Continue. Select the flight at 1 p.m. The payment information is pulled up from my registration data. Enter credit card number and an expiry date. Please do not get excited about this. This is not my valid card information. Click Continue. An invoice appears stating the booking is done. Check the itinerary. Click on the itinerary button. In the itinerary section, the booking done is reflected. Click Sign Off to sign up from the application. Our business process is recorded. Click Stop in the floating toolbar to stop recording. This is the code generation pop-up window which will generate the code for us. If you observe, the ViewGen wizard has automatically proceeded to the next step in the recording pane. It is showing a recording summary in the task pane. The recording summary includes the protocol information and a list of actions recorded. For each step performed during recording, ViewGen has generated a snapshot, a picture window during recording. Thumbnails of the recorded snapshots are displayed in the right pane. Now, Let's save the script as demo1. Now we have recorded a travel agent logging in, booking a flight, seeing the itinerary, and finally logging off from the application. What Views generator has done is recorded all the events done from the moment start button is clicked till the stop button is clicked. Now if the need arises and if you want to see the recorded script, there are two ways: to view the script in the script view and to view the script in the tree view. The tree view is an icon-based view that lists the actions of the view users as steps. Script view is a text-based view that lists the actions of the view users as functions. So first, the tree view. To view the tree view, you can go to View, select Tree View. Alternatively, you can directly click the Tree View icon in the toolbar. In the tree view, for each step performed during recording, an icon and a title appears in the tree. Not only that, in the right hand side, you see a snapshot of the action performed. Along with that, you have the client request and the server response recorded. Now the advantage here is that the snapshots make the script easier to understand and easier to share between engineers because you can exactly see which screen was recording during recording. Now let's look at the script view. As you are aware, the script view is a text-based view that lists the actions of the view users as API functions. To see the script view, click View, Script View. Alternatively, you can select the script view icon from the toolbar. In the script view, you see the script in an editor which is color coded. You have an option to type C or Loadrunner API functions as well as control flow statements directly into the window. So that's how recording takes place in View Generator. Let's have a look into transactions. The first question is, why add Loadrunner transactions? Only means of measuring performance, helps to identify performance problems, breaks complex actions into simpler, measures high business risk transactions, allows performance comparison between different loads. What Loadrunner transactions measure? It measures the system performance resulting from one or more user actions. A pictorial demonstration. Transaction 1 measures the login actions. Another transaction 2, measures everything that happens after the login. Transaction 3 is a sub-transaction under transaction 2 which measures only the save order action under the transaction 2. Let's have a look in the Loadrunner. In order to insert a transaction, you need to open the transaction creation wizard. In the enhancement section, under the task pane, click on the link Transactions. The transaction creation wizard displays the thumbnails of the different steps in the script. To enter a new transaction, click on the button New Transaction. The wizard prompts you to place a marker before the step from which you want to start recording a transaction. Let's place it before the third step, that is the Search Flights button. As soon as a marker is placed, the wizard prompts you to place an end marker. Let's put it before the fourth thumbnail, that is reservations.pl. As soon as the end marker is placed, the wizard prompts you to give a name to the transaction. Let's give it the name Search Flight. On right hand side of the wizard, what you see is a list of all available transactions embedded in the script. Also, action wise filter can be placed. In the tree view, you can also see your transactions inserted here. Once a script is recorded, playback is necessary to ensure that recorded business process has been recorded correctly. So in case there are errors in recording, they can be corrected. The playback model in Loadrunner begins with the login action. It is used to record or log in on related events. Recording is optional in this action and can be iterated only once. Next, various actions which emulate business processes are executed. The number and naming of user actions varies from script to script. The actions in this section can be iterated. The last action is the log off action. It is used to record or logging off related events. Again, recording here is optional and the action can be iterated only once. Let's go ahead and play back the script that we have recorded earlier. This is the same script that we recorded earlier. In order to replay, in the task pane under the replay section, click the verify replay link. Before you actually go ahead and start with the replay, you need to set the runtime settings. To set the runtime settings, click on the link Open Runtime Settings in the instruction pane. For a note, these runtime settings are applicable only to the replay in view generator mode and do not have any effect on the runtime settings of the scenario in the controller. More on this later. Click on the node Run Logic under the Journal tab. The run logic is basically the number of iterations of various actions would be performed. For our replay purpose, let's keep the number of iterations to 1. The pacing node gives you the time interval between two actions in case the actions are iterated. The log nodes gives you the various replay log settings. The think time emulates the time taken by an end user between any two transactions in order to process his next action. For replay, it's best to ignore the think time. Next, select the node additional attribute. This is similar to global variables in certain programming languages. The attributes are declared here and can be used throughout the script, and their values can be changed centrally here. It helps in management of dynamic values. These are the various miscellaneous settings. The speed simulations help simulate various connection speeds between client and server. Say, for example, 28.8 kbps, 56 kbps, 64 kbps, and so on. For replay, let's use the maximum bandwidth. The browser emulation instructs the user to replay your script in IE instead of the default Mozilla browser. So system responses to various browsers type can be emulated. These are the various integral protocol related settings. The proxy is required when accessing the internet using a proxy, usually in a company or a school environment. These are the various preferences and the content checks. So let's stick to the defaults. Press OK. Click the start replay button. This is a replay. No errors were detected. So this is how the replay works. Correlation can be done in two ways: manual and automatic. Let's look at manual correlation first. Manual correlation can be done in three ways: First, manual coding. Here the performance engineer will manually check the Loadrunner script to correlate the dynamic values. It's a tedious process. Second, snapshot comparison. In this method, the script is run in playback mode and the resulting snapshot is compared with the snapshots in recording mode. The differences are correlated. The third and the recommended method of correlation is vuser comparison, where the same script is captured twice and a win difference is done on a script, and the differences are correlated. So let's see how the vuser comparison is done. Correlation can be done in two ways: manual and automatic. Let's look at manual correlation first. Manual correlation can be done in three ways. First, manual coding. Here the performance engineer will manually check the Loadrunner script to correlate the dynamic values. It's a tedious process. Second, snapshot comparison. In this method, the script is run in playback mode and the resulting snapshot is compared with the snapshots in recording mode. The differences are correlated. The third and the recommended method of correlation is vuser comparison, where the same script is captured twice and a win difference is done on a script, and the differences are correlated. So let's see how the vuser comparison is done. I have recorded and saved two scripts, vuser_1 and vuser_2, which emulate the same business process: login in Mercury Tour, booking a flight, view itinerary, and fourth, sign off. The steps involved in vuser comparison correlation are: find the dynamic value to capture, find the server's response containing the dynamic value, capture the dynamic value in a parameter, replace every occurrence of dynamic value with parameter, check the changes. Let's look at each step one at a time. What I have with me is a vuser_1 script open. If you remember, the script was recorded in one of our earlier tutorials. As I've already told you, I've recorded and stored another script emulating the same business process as vuser_2. To find the values to correlate, I'll use tools, click on compare with vuser, select the script vuser_2, click open. The differences between the scripts are highlighted in yellow. This essentially means that the parameter value changes from run to run, which are highlighted. So most probably these values should be correlated. The reason I use the word probably is because the tool shows four parameters in difference. First, the think time. Second, the user session value. Third, login.x and login.y. Login.x and login.y are the x and y coordinates where the button login is clicked. Even if these values are hard-coded, the script will not fail and will not affect the functioning of the website as well. The third difference is the think time. As you are aware, the think time emulates the user pauses between activities. So a variation in amount of think time can be. The fourth value and the difference is the user session. Session ID is unique and needs to be correlated for the successful script run. In fact, this is the exact value which is causing our script to fail. So now we have zeroed in on the value to correlate. Second step, find the server's response containing the dynamic value. Before that, close the win difference utility. Here on, you can use either of the two scripts, either vuser_1 or vuser_2. I'll stick to vuser_1. To find server's response, we need to run the script. So I click on the verify replay link in the task pane. Before running, in the run and time settings, in the log, enable extended login, click OK. Click the replay again button to replay. The script will obviously fail. If you scroll down in the instruction pane, there is a link replay log. Click on the link replay. Switch to the script view. Press Ctrl plus F and enter the value user session. We need to find this parameter in the server's response. If you see the parameter user session appears in the form with action error.pl, if I double click on the value of user session in the recording log, in the script you will see the server's response. So I can safely say that user session appears in the Mercury Web Tools page under the action error.pl. To track this parameter in the server's response, click the tree view. Select the Mercury Web Tools URL. We seen it. Select the server's response. Switch to HTML view. Click the node body. Here you see the action error.pl. And in the HTML response, you see the value of user session. So our second step of finding the service response containing a dynamic value, it's done. Step number 3. Capture the dynamic value into a parameter. To do this, highlight the value starting with 9 ending with Q of user session. Right click on the highlighted portion. Click the create parameter option. A pop-up window is shown. If you press yes, you replace all occurrences of dynamic value. If you press no, you will have to manually replace the occurrences. Well, it is recommended that you manually replace the occurrences. So I'll select no. If you observe before the Mercury Web Tools, there is another step created, which is nothing but capturing the parameter value. If you observe this step in the script view, you see a method created, which is WebRegSaveParam. The WebRegSaveParam is an inbuilt function used for parsing. In the syntax, it accepts three arguments: the parameter name, the LB, and the RB. The LB is the left boundary after which the value to be passed appears. RB is the right boundary before which the value to be passed appears. In the service response, the value 97253 ending with HTQ appears between the left boundary, user session value equal to, and the right boundary of a bracket. Accordingly, the WebRegSaveParam function is created as follows, with a suitable parameter name WCSParam_text1, with the left boundary and a right boundary. Remaining parameters relate to the location Step 4. Replace occurrences of dynamic value in the script. To do this, in the script view, press Ctrl F. Enter the name of the parameter to be correlated. There is only one occurrence of the parameter user session in the script. Replace the hard-coded value of user session with the parameter. I'll just copy the name of the parameter from top. The brace brackets just indicate value of the parameter WCS param underscore text1. The fifth and the last step is to check the script. To do this, click the Verify Replay link in the task pane. Scroll down and click the button Replay again. As you see, no errors detected and the script runs fine. In this way, you can do manual correlation. Automatic correlation. In automatic correlation, the correlation needs are taken care of by the Loadrunner itself. Various steps involved in automatic correlation. Replay the script. Select the values to correlate. Verify the script. To demonstrate automatic correlation, I'll use the script recorded in tutorial number 8. Again, it is the same script recorded post the admin adjustment we did in Mercury Tours, which was emulating the business process of logging in Mercury Tours, booking the flight, viewing the itinerary, finally sign off from the application. So I'll switch to the script vuser_2. What I have is the vuser_2 script open with me. The script is failing in replay due to uncorrelated values. In order to proceed with automatic correlation, I scroll down the instruction pane, click on the link Show and Resolve Dynamic Server Values. The values in contention are displayed in the correlation results. I need to select the user session value, click on the button Correlate. A green check mark is displayed indicating that the value was correlated. In fact, if I check in the script view, the webreg save param function was implemented and user session value is replaced by the parameter. So this step which we just did manually is done automatically by Loadrunner. To verify the correlation was done properly and the script works fine now, I click replay. The script is in run mode, it's working well and fine. And you see this? The replay summary shows that no errors are detected and the script is working fine now. Automatic correlation is not the recommended method for doing correlations because at times it is buggy. So the suggested method is to do manual correlation. Parameterization. Let's investigate first the need for parameterization. In a sample script, while booking the flight, we chose seating preference as IL. In real life scenario, users will choose different preferences. To make a test as close as possible to a real life scenario, we need parameterization. So let's look at the advantages here. Parameterization provides the ability to test your script with different values. And second thing, it reduces the size of the script since it makes your script dynamic. Now let's look at the steps that need to be performed in order to parameterize. Step number 1, replace the constant values in Vuser script with parameters. Step number 2, settings the properties and data sources for the parameters so different values can be selected at runtime. Now let's go ahead and parameterize the seating preference option in our script. Just for a note, we're working on the same script that we have recorded in the earlier tutorials. I'm in the tree view right now. I double click on the submit form reservation.pl icon. A step property dialog box opens. Basically, this box gives you the various data sources and their values. In order to parameterize any of the values, in our case, we'll go ahead with the seating preference. Click on the ABC icon. Here, you can specify a valid parameter name. Seating preference. I have an option to choose multiple parameter types. It could be a load generator name, a random number, maybe something coming from a table, a unique user-defined function, and so on. Most of the times, you will select the parameter type file. Step number 2 is to set the data sources. For that, you need to click on properties. If you select parameter of the type date and time, you can select the multiple formats in which the date can appear in. If you select the parameter type to be a random number, you can specify the minimum and the maximum number between which a random number would be generated, also the number format. If you want your parameter to come from a user-defined function, you can specify the name of the function and the library file from which it is coming. If you select your parameter to be coming from a file, you could create a table. A pop-up is shown which creates a .dat file in a default location. Click OK. The default value is populated here. To add more values, click the add row button. Enter another valid seating preference, that is window. Add row again. Enter another seating preference as none. These are the 3 valid seating preferences. Here in this section you can mention the selection criteria. It could be either sequential or maybe random. Let me select random. Close the script. Click OK. In the dialog box, I can very well see the seating preference is parameterized. I click OK. I run the script now. The script is replaying right now. If I check the replay log, you send across as IL. Let me run the script again. In the replay log, I check the seating and the value sent is window. Verification checkpoints. Many times while surfing the internet, contents are not downloaded and displayed completely. Display of data at client machines is an integral part of a business process. To ensure that all business processes have completed end-to-end while the server handles concurrent requests, we need content checks. Loadrunner provides 2 types of content checks: test check Image check. These checkpoints can be added during or after recording a script. Checkpoints added in a script stores the expected value, compares the actual value in the web page to the expected value during playback, and reports the comparison result status as either pass or fail. Let's begin with a test check. Let's create a test check to verify the text file departing appearing on the client screen. This is a sample script that we recorded earlier. I click on the content checks link under the enhancements tab. To put a test check on the text flight departing, I need to scroll down to the thumbnail which contains that particular text. I click on the reservations.pl thumbnail. In the page view, I can see the text. I highlight the text flight departing, right click on the option add a text check. Many a times the watcher user generator won't allow you to create a text check in this manner. The way around is click on the tab server's response, click HTML document, click on the body node. In the flight selections form, you see the text flight departing, highlight it, right click on the text, click add a text check. There are many options provided here. Not only that, you can choose to search text between starting text and between the ending string. Let's stick to the defaults here. Click OK. If you observe in the tree view, a step is created by the name regfind, which is nothing but your text check. Next, let's do an image check. Let's create an image check for the sign off button with all text equals to sign off button. To create an image check on the button sign off button, I select the image sign off button, click the server's response. I see the source as fma gateway.jpg. I highlight it and copy it. Before the step image sign off button, I click insert new step, expand the node web checks, select an image checks. Just for information, all the steps that are highlighted in the tree view can be explicitly added using add step. So I can add a random waypoint, a transaction, and many other features. I select image check, click OK. Maybe the alternate text I'll give, which checks the image. Now, let's look into output messages. At certain times, we need to send information to output indicating location and other information. Output messages will appear in both the replay log and the controller's output. Let's create an output message after the application books a flight, indicating the booking was done. To insert an output message at the end of the test, I click insert new step, click output message, click enter the text, click OK, and output message. To determine how the text check, image check, and output message is seen in the output, click the verify replay. So here you see, in verify replay, I click the replay log, I switch to the script view, press Ctrl F, first text check, click find. The first line basically means is the WebRec find is started. The second line basically means is WebRec find was successful. Image check. The first step means web image check was started. Second step means web image check was succeeded. The last step shows the output message, that is flight book. Let's do it. Let's look at the controller now. What the controller does. Before scenario execution, creates the scenarios, sets up runtime configuration. During scenario execution, runs many vusers simultaneously, controls each vuser, initialization, running, pausing or stopping, displays execution status of each vuser, displays messages from each vuser, monitors server resources. After scenario execution, collects and organizes performance data, launches the analysis tool. Let's actually look at the cut. In the Mercury Loadrunner window, click on the link Run Load. The controller opens. This is the new scenario pop-up window. All the available scripts are highlighted here. For your particular load testing, you can select the various scripts. I select the scripts vuser_1 and vuser_2, which are essentially the same scripts emulating the same business process. Also, I have an option to create two types of scenarios. The first, manual scenario, wherein I explicitly specify the number of vusers and the duration of the load test. And the second type of scenario would be a goal-oriented. Let's select the manual scenario, click OK. This is a controller main window. It has two sections, the design section and the run section. The design section is used for designing the scenarios and the run section is used to monitor the scenario. The two vuser scripts are highlighted here. I can click this drop down button and change the script as well. The script path specifies the location at which the script is stored. The quantity specifies the number of vusers. Let me put it as 4 for both the scenarios. The load generators specify the machine at which the vusers will run. Click on the generators button. Here you can configure the various load generators. For the tutorial purpose, I will stick to the local host. Click cancel. Not only that, for the various scenario groups, I can specify the runtime settings. Click on the runtime settings tab. I can simulate the speed for this particular group of scenarios. So say I'll select the speed of 64 kbps. So all the vusers approaching the system in this particular group of scenarios will be simulating a speed of 64 kbps. Also, I can very well specify the browser. So I can emulate browser Microsoft Internet Explorer version 4.0. Okay. There are various other settings I can change. For vuser group 2, I select the network speed as 512 kbps. So these 4 users coming from group 2 would be emulating a speed of 512 kbps using the Mozilla browser. Click OK. The details button gives me the details of the scenario groups. If I click the view script, view generator would be launched and I would be able to see the script. Now, the scheduling. The various default schedulings provided here: slow ramp up, ramp up. Let's stick to the default schedule and click edit schedule. Here I have an option schedule by scenario or schedule by group. So let's schedule the scenario in general. Now it's highly improbable that all the vusers would be approaching the system at the same time. So to make it as close as to a real life scenario, a gradual ramp up is recommended. In the duration tab, you can specify the runtime duration. Let's select 5 minutes. In the ramp down, you can specify a gradual ramp down of the V users. Let's select 5 users being ramped down at 30 minutes. The graph, the load preview is changed accordingly. Click OK. So these are the various settings that could be performed. Click Start Scenario. The status of the scenarios and the V users is highlighted in this section. The scenario status, that is hits per second, past transactions, failed transactions, are shown here. There are a number of graphs that I can monitor. I just need to drag and drop the graph in the main section. At the bottom, I can see a legend. I can add monitors as well if I want to. I can check the details of the past transactions by clicking here, or the transactions in error by clicking here. It gives me the exact details. All this data is being captured. I can also customize the graph settings to show me 8 graphs. The test, as you see, is run now, and this is a result summary. This is the Mercury Roadrunner analyzer. To start the analyzer, you have two options. Either in the controller window, after the test is done, select results, analyze results, or in the main window, click the link analyze load test. This is the Mercury load analyzer. On the left hand side is the preview of the various graphs available. On the right hand side is the description. The first page is a summary report wherein all the transactions are listed with the minimum, average and maximum time in execution of those transactions. The 90% column is an important column which gives the time required to execute the transaction by 90% the time. These are the various graphs. I can choose to set the granularity. Right now it's set to 8 seconds. If I am working for hours and hours together, I set the granularity as 20 seconds, and all the graphs accordingly will change. I can filter the graph data depending upon various parameters like transaction name, elapsed scenario, script name, and so on. Not only that, if I find myself short of any graphs, I can just click the add button, select the graph which is not present, click OK, open graph. The graph is open in the background. It's reflected in the tree view as well as in the main pane. If I have too many graphs open, I just select the graph, click delete, and the graph is deleted from the display. Mind you, it's not deleted from the graph results folder, it's just deleted from the display. Towards the bottom, I see a legend of the various graphs. Not only that, if I want to correlate graphs, then I can select the graphs to be correlated. Say transactions per second and hits per second, I want to correlate. I click OK. The correlated graph would be reflected here, available for my analysis. In case the need arises, I need to merge two graphs, I can do that as well. So these are the merge graphs here available for you. I can add comments on the graph if required. Just to mind you, the analysis is never done in isolation. In fact, all the system stakeholders, right from DBAs, database administrators, to the network administrators, to the functional consultants, domain consultants, to the architects, to the technical consultants, come together, analyze the graphs. There is a brainstorming session that goes on, and eventually a performance meteorites are analyzed and acted upon.